UplinkFast is a spanning tree protocol feature that is designed to improve convergence. How long does it take to transition a blocked port to the forwarding state by default? Well, let's pretend this is our root bridge. This is our current root port down here, and this is our blocked port within the topology. How long will it take for the blocked port to become the root port if this root port fails? Well, it will become the root port immediately because this failure is a direct topology failure. It's happening on ASW, so it knows automatically that the other port has to be a root port. But because of spanning tree protocol timers, in order to transition to the forwarding state, it will take approximately 30 seconds. As the port transitions from the listening state to the learning state and then to the forwarding state based on those forward delay timers. So if we go out to ASW1 and we look at spanning tree for VLAN 10, take a good look here at gigabit 0/1. It is currently the root port. It's in the forwarding state. Gigabit 0/2 is the blocked port, and it's an alternate port. So already ASW1 knows that gigabit 0/2 is going to become the root port if the root port fails. But how long does it take? Well, let's examine that. Debug spanning tree events. And we can see here that if we shut down interface gigabit Ethernet 0/1, that, we got our debugs turned on. It will take approximately 30 seconds. So there's the listening state. We immediately made gigabit 0/2 the root port for VLAN 10 and put it in the listening state. However, it takes 30 seconds before it can go to the forwarding state, even though it's the root port, simply to make sure that there is no loop in the topology. So we're in the learning state now, and then once that's complete, we will be in the forwarding state. Then once we're in the forwarding state for gigabit 0/2, I'm going to bring back up gigabit 0/1 because we want to examine now how long it's going to take to transition this port. So here's our root port again, here's our block port. How long is it going to take now if we have UplinkFast enabled? Well, with UplinkFast, we're automatically going to transition it to the root port, but to go forwarding, I'm saying it's going to happen immediately. We won't have to wait. So how do we enable UplinkFast? Well, we enable it globally for the entire switch. You do not do it on an interface by interface basis. You do it globally. And you do it with the spanning tree UplinkFast command. So let's examine that. We'll go back out to ASW1 and go to global configuration mode and type in spanning tree UplinkFast. So now it's enabled. A few things are going to happen in the background in order to get UplinkFast set up for our spanning tree topology. And then once it's done, let's see how fast gigabit 0/2 will transition to the forwarding state now when gigabit 0/1 fails. So interface gigabit Ethernet 0/1, and let's say shut down. And we'll see how fast gigabit 0/2. There you go, done. I didn't even have a chance to finish my sentence, and it already transitioned to the forwarding state. So let's shut off the debugs. What do we see here? It says right here, spanning tree UplinkFast. Gigabit 0/2 moved to the forwarding state because of UplinkFast. We did not have to wait to transition to forwarding state. Now here's something that's really important to realize. When this quick transition happens, the switch that did the transition is going to have to make sure that MAC addresses that were originally learnt out gigabit 0/1 are now learnt out gigabit 0/2 in my topology. For example, if this is now down and this is now the new root port, well, originally all the traffic to go to this PC was coming this way. So all the switches knew about this MAC address right here. They knew about that MAC address using the path here, this path. Well, here's the problem we run into now. The root port's here. This is now blocking. It's down, meaning that if they try to send frames this way, what happens? They don't make it. So the switch needs to send out bogus frames. So just these random frames it's sending out with the MAC addresses in them. So this PC's MAC address has to be sent out this port now. So that way this switch can learn it on that port. And then the other switches likewise. So now the new path can be reached this way. That's the key right there. If this does not occur, then we will have a discrepancy between the spanning tree topology and the MAC address table. That's what will occur. So in order to make this process seamless and quick, the switch has to send out those bogus frames with the end station MAC addresses out that port at the same time that it's transitioning to the forwarding state, so all the other switches can now update their MAC address table and go the right way, or else the traffic will still flow the wrong way. So that's an added enhancement with UplinkFast to make sure that the transition happens really, really quickly. If we want to verify UplinkFast, we can type in show spanning tree UplinkFast. Let's do that right now. Show spanning tree UplinkFast. And I want you to notice here that it's enabled globally for the device. We have had 2 transitions so far because of UplinkFast. And lastly, look at these. Those are those bogus frames that are sent out, the addresses that are transmitted. We've transmitted those out of gigabit 0/2 up through the new spanning tree topology so the other switches could rewrite their MAC address tables based on these frames that they receive. And then down below we can see the VLANs that are participating with UplinkFast and the interfaces that are forwarding now because of that UplinkFast transition. So where are we going to perform UplinkFast? Think about it. It's going to be based on where those block ports are, and that's at the access layer. Typically, root bridges at the distribution layer, and then down at the access layer, we have the access layer switches, which are going to have root ports, maybe root ports, designated ports as well, and those block ports to prevent the loops from happening in the topology. So it's best implemented at the access layer, so that way there are those root ports. When they go away, the block ports can transition immediately to the forwarding state. And remember, you're not going to need this feature with Rapid Spanning Tree Protocol because it's already integrated into the protocol itself, so you don't have to turn it on.